Okay, so going back to the question, in 2016, more than 200,000 students took the AP Statistics exam. Okay, of these students, 14% earned the highest score of 5 on that test. Find the probability that if I took a random sample of 300 who took the same test, that sample would be higher than 15%, 15% or higher. Okay, so if I took all of the students, if I got all the students in one big hat, all 200,000 plus that took the test that year, 15% of first 15% of them, or 14% of them scored a 5 or more, or scored a 5. 5 is the highest you can get. Now, I'm not taking from the big pot anymore. I'm just grabbing 300 of them. So I have 300 of those in my hand. What's the probability that if I take all of these 300, that 15% or more scored a 5? So I'm not taking from the whole, I'm just taking a sample. Okay. So when we're finding probabilities from a sample, remember, there's a couple things we have to do. First thing we have to do is identify the parameter. Is it a means question or is it a proportions question? Well, on Thursday, we said it's a proportions question. We talked about it. There's percentages, 2 separate percentages, and nowhere does it talk anywhere about average or means or anything like that. Okay. So in words and in numbers, what does P equal? Well, P is the true proportion, always starts true proportion of students who scored a 5 on the test. That's the parameter. That comes from the population, that big 200,000 plus students. Okay. And that number they tell us is 14%. So P equals true proportion of students who scored a 5 on the 2016 AP Stats test. And that number is 0.14. Okay. Number 1 done. Number 2, list everything that we know. Everything that they give us in the question, list it. Well, they also say n, small n, lowercase n is 300. That's the sample size. Big N is 200,000 plus. They don't give us a specific number, but they said it's over 200,000. And I think that's about it. That's all the information they've given us. Okay, that's step 2. Step 3 is, since the question is referring to the sample of 300 students, we have to do our assumptions and conditions for this question. Okay, we did this on Thursday, but if you forgot, it's on the first page, right here. Okay, the first 2 are always the same, no matter for proportions or means. And then depending on whether it's a proportions or means, we're going to check it that way. Okay, so let's set this up for this problem here. Okay, so conditions or assumptions, right? We always have to do this if it's a probability question based off a sample. Okay, and then check. So the first one is it an SRS? So did our sample, was it taken in a random method? Yeah, it's stated, right? It said random sample. Random sample of 300 students. Okay, oops. So stated. Stated in the prompt. Stated. Okay. Next one is the 10%. 10%. Right? Our sample has to be big enough. Big enough is number 3, but small enough that it doesn't go over 10% of the population. So 10% condition. Okay, so it has to, n has to be less than or equal to 10% of big N. Okay, so let's see, small n. We know that number. They gave it to us. 300. Less than or equal to 10% of big N. Big N, they didn't give us an exact number, but they said it's more than 250,000. Or 200,000, sorry. Okay. So worst case scenario, it's 200,000 or 200,001. Right, more than 200,000. Worst case scenario, that's as low as it'll go. So Is that a true statement? Is 300 less than 10% of 200,000? All right. 10% of 200,000 is 20,000, right? That's smaller, yeah. We're good. Yep, we're good enough there. Okay, the last one is normality. Check for normality. Okay. So be careful because there are two ways to check normality. This always gets students. Which one do we choose? Well, we're going to choose the first one, the left, sample proportions, because it's a proportions. So n times p, it says q there. I don't know why they use q. It's supposed to be n times 1 minus p. Q is the same thing as 1 minus p. I don't know why they changed the letters, but yeah. Okay, so let's go back 2 R's and check that. Okay. N times p is greater than or equal to 10. And n times 1 minus p is greater than or equal to 10. Okay. N is 300. What was p? 0.14. So when I multiply 300 times 0.14, I get 42. 42 certainly is bigger than 10 or equal to 10. So that one's okay. I'm going to do that again, except now 1 minus p. 1 minus p is 86%. Well, if it was big enough for 14%, it's going to be big enough for that. So let's see. 258. Yeah. Good to go. We're happy. We won't see this early on, but we might see this later chapters. What happens if one of these doesn't get a blue check? Nothing. Okay. One of these were to fail, we would just take note of it in here and move on. We don't, doesn't stop anything we do. Some students say, oh, number 2 failed, so I stop and I don't do the problem. Yes, you do. You keep doing it. Okay. You keep going as if it didn't fail. Okay. Okay. So number 3, check all assumptions. Now, number 4, let's actually do the problem now. Okay. So we're going to use the normal model. Since number 3 panned out, since number 3 passed, we're going to do the normal model. Okay. So I'm going to draw normal model. What's the mean for this question? Or what's the center? Yep, 0.14. That's P. That's the true parameter. Now the question is asking for 15% or more. So that's going to be, or more means shaded to the right. So that's what we got to find. We got to find that decimal or percent. Okay. Z-scores, anytime we're using, anytime we're doing normal calculations, we always use Z-score. So Z-score, 0.15 minus 0.14. Uh-oh, standard deviation. How do we get our standard deviation? Where is it, or where do we find it? There you go. Yeah, we use our formula that we had last time, which is in your notes, and I will show you right. Is it in this one? Nope, it's in this one here. This guy right here. All right, so in this case, this was our mean, right? 0.14. They gave that one to us. And this is what we're going to use for our standard deviation, which is, again, these guys you do not have to memorize because they are given to you on the test. Okay. So let's go back to our question. Okay, so first we got to calculate that guy. So that guy is P1 minus P over N square root. So P is 0.14 times 0.86 over N, which is 300 in this case. Go 3 spaces past, and what do you get when you multiply? Multiply, divide, square root. 0.0200. Anybody else disagree? Good? Okay. Since it's 2 zeros, we'll just cut 1 0 off. Okay. That number is going to go at the bottom. Okay. Now we can do z-scores. So we get 0.01 over 0.020. And we get a z-score of 0.5, yeah, 1/2. That is correct. Okay. Go to my tables. Look for that z-score, positive 0.5. And we get 0.6915. 0.6915. So the question is that the blank side of the curve, or is that the blue side of the curve? That's the blank side, right? So to get this guy, I got to go 1 minus that. 3085. There you go, a little over 30%. Last step, summarize the answer in words. Okay. So in order to summarize the answer, you just answer the question, right? The question said, what is the probability that a random sample of 300 students would get what's the probability that if I took a random sample of 300 students that 15% or more of them would have a 5? There's a 30.85% chance that 15% or more of the 300 Perfect. You can use the decimal. If you use the decimal, say probability. The probability is 0.3085. If you're going to use percent, don't use the word probability. Okay? So if I'm going to use the percent, I would say exactly like Aldrin just said. There is a 30.85% chance. Say it again, Aldrin. What did you say? That 15% or more of the 300 selected students scored a 5 on the exam. Scored 5 on the 2016 AP Stats exam. Of the sample, right? You said something about the sample? Yeah, the 300 selected students. That 15% or more of the 300 selected students. That's better. Yeah, your answer is better than mine. Let me change it. That's 15% or more. Say it one more time. 15% or more of the 300 selected students. Of the randomly selected students scored a 5 on the 2016 AP Stats exam. Okay, so there is a 30.85% chance that 15% or more of the randomly selected students scored a 5 on the 2016 AP Stats exam. Okay, it has to say that. Now, does it have to be word for word? Obviously not, but yours has to say the same thing. Okay, just be careful when you read it. When you read it back to yourself, if it says the same thing, then it's okay. Okay, so if I was to reach in there, so overall in 2016, 14% of the students got a 5. But if I was to reach my hand into the pot and only pick 300 students, there's about a 30% chance, 31% chance that those students I have in my hand, 15% or more got a 5, right? Okay, that's what that's saying. Okay, so now let's look at the next question. So read the question to yourself. Just read the prompt. Don't read A and B yet, but read the prompt. Read the prompt to yourself. Okay, so does this fall into a proportions or means question? Yeah, you see a lot of means, right? A mean of 5.6, standard deviation of 4.1, and calculate the mean number of absences, right? A lot of means. That means we have averages, so it's a means question. So a lot of it's the same, steps are the same, but a lot of the steps are different. Some of the steps are different. We're still going to use the same steps we did earlier for proportions. The only difference is some of those steps are a little different, tweaked. Okay. So let's highlight some stuff. If you did it already, some of you guys I saw underlining, great. Always highlight, underline stuff because that's what we're going to be using. Okay. So the number of absences last year for students at a large high school has an average of 56 or 5.6 days with a standard deviation of 4.1 days. Suppose we were to take an SRS of 80 students, of last year's students, and calculate the mean absences for the number of the sample. Okay, so now let's start at the beginning. First thing, a mean of 5.6. Is that a parameter or a statistic? So what's the difference between parameter and statistic?
One deals with proportions, the other deals with means.
Nope. There you go. One is for the population. One describes the population. One describes a sample. So 5.6, does that represent the population or does that represent just a sample? That's the population, yeah. That's the population right there, right? So we're going to use 2 letters. We're going to use, anytime we're talking about, we're using these 2 guys here, right? These 2 symbols here, mu and X bar. Those are the only 2 symbols we're using for these guys. So since it's a population, we're going to give it this symbol here. Okay, so I'm going to label that. Oops. Okay. The standard deviation goes with that mean. Okay, so that means that's a standard deviation. Population standard deviation. SRS of 80. Okay, there's our number, 80, right? 80 in the sample. And then that's all they give us. That's all the information they give us, right? Okay. First question doesn't ask us for probabilities. It just says identify the mean of the sampling distribution. So what this is saying is if I took an infinite number of samples of 80, so if I took 80 students, so I have every name of the student, every student that went to this school last year, if I had their names in a big hat, however many there are, and I took 80, found the average days they missed, put them back in the hat. Took another 80, find the average of those 80, put them back in the hat. Kept doing that forever and ever and ever and ever and ever and ever and ever. What would those means be? What would the average be of all of those samples? Exactly the same as the population. It would be 5.6. So we say the mean of all of those samples I took would be exactly the same as the population. Okay. The next one says calculate and interpret the standard deviation of all of those samples that I took. Well, standard deviation is right here. I have one right here. So that's what I'm going to use. So the standard deviation is the population standard deviation divided by the number in the sample, square root of that. Okay. So from the prompt, it says the standard deviation was 4.1. The sample was 80, so root that.
.4583.
Let's see. Square root 80. And then 4.1 divided by that. 0.458. Yep. Okay. Okay. Calculated it. We're done. We got the calculation. Interpret it. What does it mean?
On average, each absence varies from the mean by 0.458.
Close. Not varies from the not absences. So let's go back. We did a question like this, except it was with proportions. But again, the idea was exactly the same. So let's go up to this one right here. The first problem we did. Okay. So this one we said since the mean of all the p hats was 0.2, each p will vary by about that much percent. Okay, so we have to talk about this guy. Well, we have this guy. We just calculated that guy. So let's start it that way. Since the average of all of those samples would be 5.6, each. So if I took all of those samples of 80, found the average of all of them, it would be 5.6. But that refers to just one. So if I took just one, it might be 5.6 average, it might not be. There's some variance, there's some vary there, right? So each of those, each sample mean, so sample mean will vary by 0.458, by about half a day. So if I took just one sample, it might be 5.6, it might not be, but it's on average, it's going to vary by about a little less than half a day. I should put days for that one. Okay. And then the last thing I have to do for this question wanted me to do 3 things. The last thing I got to do is verify the 10% condition. Okay. So let's see, condition, check. So the 10% condition is step 2. Okay. So that one says less than or equal to. Okay. So in this case, n is 80, less than or equal to 10% of big N. So they don't give us the number of big N, but do we know how to describe the population? Number of students, say what? Say it one more time.
Number of students at a large high school.
Yes. Students at this large high school. Okay.
And we just check it, right?
Yeah, just check it. It would have to be over 800, and if it's a large high school, it's going to be, it's not considered a large high school unless it's in the thousands. Okay. Done. There we go. We're done with that question. Okay. Let's see here. And that was all we have for that question? Yep. Let's move on to the next question. All right. Okay, so different prompt now. Tall female problem. So adult female heights in the United States are roughly normally distributed with a mean height of about 64 inches and a standard deviation of about 3. Okay, so this is what I think is important. And we'll talk about why I think it's important. Those 3 things right there. I'm not even to the question, but already those 3 things I think are important. The first one, why is the first one, why I shaded the first one? Roughly normally distributed. Why is that important, do you think?
Why is roughly normally distributed important?
Why are those 3 things important?
The mean's important.
Okay, the mean's important because.
So the mean of all adult female heights.
Okay, so is it a parameter or is it a statistic?
No, it's a parameter.
It's a population, so it's a parameter. Good. 64. How about the standard deviation? That goes with 64, right? So 3. Good. Okay, those are where I thought, that's why those are important. But why is the first one important? We'll skip it. We'll come back to it. We'll come back to why it's important. You'll find out why it's important. Okay, so the question, first question about this is, what is the probability that one randomly selected female is taller than 67 inches? So you see how I put in capitals 1, the number 1. Why did I put that? Why do you think I did that? This guy right here. Why do you think that it was important for me, or that I wanted to convey that it was only one student or one female? Sorry. Okay, don't worry about it. We'll skip it. We'll come back to it. Trust me, you're going to need it to do the question. You'll answer the question in due time. You might not see it yet, but you will. Okay, so what do we do now? Yeah, I was waiting for someone to say, identify the parameter, list all the parts, check assumptions, conditions. Why can we skip step 1, 2, and 3 on there?
Because it says it's already normally distributed.
No, that's not why we can't skip all those steps. Why can we skip steps and go right to normal model? But last time it asked for the probability, right? It's been asking for probability, and sometimes we have to do assumptions and sometimes we don't. Why do we not have to do any of those for the first one, for this guy? Not because it's a mean. No, we're definitely going to use that, but not that. Go back to the first page of these notes. So these notes here. What does the first thing underneath the title say?
Proportions and means? Oh, no. When using a sample?
Read the whole thing.
Oh, when using a sample to infer about a population. We're not talking about that. We're just talking about one.
This is not a sample. Where does it say anything about a sample in there? No, one is not a sample. If I had the names and the heights of all adult female women in the United States, and I took one of them, that's not a sample. That's a chapter 2 question. You've done this question in chapter 2. I think you did this exact same question in chapter 2, right? We didn't need to do any of the assumptions or conditions because it doesn't come from a sample. It comes from one, not a sample of 20, not a sample of 30, not an SRS of 50. It comes from one. So we don't need to do all that stuff. We go right to what we did in chapter 2. The average is 64 for the population. 67 is bigger, and it says taller than, so that's going to shade to the right. Okay. So we got 67 minus 64 over 3. It's one whole, or 1.00, right? So let's go to my table. 8413. That's talking about the big unshaded part. So if I want the shaded part, I subtract
1.384.
So 1584. 1587. What did you say? Wait, let's see.
1 minus 0.8416.
13.
Oh,
13, yeah.
13.
There we go. Okay. Now we just have to interpret that number. There is a 0.1587 probability. I'm using probability, the word probability, so I'm not using percents. Okay. That the chosen female is taller than 67 inches. What's up?
There's for video production,
Uh-huh.
and they want to answer for your question. That's okay.
Can you guys come back later?
Yeah.
Yeah, we're right in the middle of something, yeah. Okay. All right. Go to the next question. Tell me what the difference is between that question and the question before it.
Random samples.
We have an n, right?
Samples.
What is it?
The proportions. Proportions.
Yeah, but what is the underlying part? What is that?
Randomly samples of 10 females.
What is that? There you go. N equals 10. That's our only added piece of information they've given us. Okay? So, are they asking about probability? No, they're not. Okay? They're just asking us to describe the distribution. Okay? We haven't done this in a while. We've done it definitely lots and lots of times. But we haven't done this in a while. Describe the distribution. What does that mean when I say describe the distribution? Shape is one thing we have to tell. Not range. Close. Spread is another thing. And what's the third thing we have to tell about? Shape, spread, center. Those are the three things we got to comment on. Shape, center, and spread. Okay? We don't have to find any probabilities, but we do have to comment on shape, center, and spread. So let's do shape first. Since doesn't matter, order doesn't matter as long as you do each of them. How do we know what shape it's going to be? So not the population. I'm talking about the samples of 10. So I have every single adult female in the United States, their name in a hat. I grab 10 of them. I find their average height. Put it on a graph, right? Put a little X on the graph like we did with the cards. Put their names back in. Grab another 10. Find their average height. Put an X on the chart. Put them back in. Keep doing that many, many, many times. I have a chart now of X's, right? Just like I did for my cards. Okay, it's going to look symmetrical. How do we know it's going to look symmetrical or normal? How do we know that? There you go. It's stated, right? That's why I highlighted this part, because I knew we were going to need that, right? That was going to answer one of our questions. It's stated. So we would say roughly normal. Because stated. Or I should probably put that's bad grammar. I should put stated as roughly normal. Okay. So if that's true, then all of my samples of 10 are also going to be roughly normal. Okay. Next one was center. What's another word for center? The middle or the mean, right? So what do you think if I did that? Samples of 10, find the mean. 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 There you go. It'd be the exact same as the population. And the population is 64 inches. Good. The last one is spread. Okay, so spread. Spread. So when we're talking about spread, what are we talking about? Not the range. Variability, that's another word. Also talking about, there you go. Standard deviation. Variability, spread, variability, standard deviation, they're all the same. They all refer to the same thing, right? The reason I wanted standard deviation is because we have a formula for that. So I can use the formula to figure out what the spread actually is. It's stated for the population. It's definitely stated for the population. But because I'm taking samples, variability is going to go down. Okay? So The spread, the population was 3. I took samples of 10.
0.9486.
86.
Yeah, just round up to 9.
Yeah. All right. Oh, inches?
Yeah, it's the unit. IN.
Inches.
Freedom units.
Okay. So Josh said it earlier, 3. What did 3 represent?
The standard deviation of the population.
That's the whole population. Counts every adult female in the United States. This number is smaller. Why?
The sample. There's less people in the sample, which means there's less variability.
Yeah, there you go.
Oh, right. Less numbers.
3.
Or less samples, less variability.
The only time I would use 3 is if I chose one female out of there, and that standard deviation would be based on that one person. Well, I'm not choosing 1. I'm choosing 10 at a time, right? If I choose 1 at a time, that's 3. But I'm choosing 10 at a time. So if I choose 10 at a time, the more I choose, the less the variability. So what do you think if I did, instead of 10, I did 100? 100 females at a time. That would go down. Yeah, it would go down quite a bit. Okay. Variability, we want variability to go down. Okay, good. Good. Okay, so now what I want you to do is I want you to do letter C on your own. Do letter C on your own. This one's asking for a probability. Same prompt, same everything. This is the last thing we'll do today. Okay? So do all parts needed of this question. Okay, I'll give you about 5-6 minutes and then we'll go over it the last few minutes.